And hello everybody, here are your notes for special right triangles. And there's going to be two types of special right triangles that we're going to study. Basically we're going to memorize the pattern that exists, or the relationship that exists between the legs and the hypotenuse. So the first one is going to be a 45, 45, 90. So 45 degrees, the other angle is 45 degrees, and this is going to be 90 degrees. So you're going to have 45, 45 here, and you're going to have a 90 degree angle. And since both the angles are the same, 45 and 45, that means your two legs are going to be congruent. And then the other special triangle is going to be a 30, 60, 90. So this one is going to look a little bit different. One of the angles will be 30. The other one will be 60. And then you'll have your 90 degree right angle. So those are going to be our two special right triangles, and we're going to talk about the relationship between the sides in those two different cases. So looking at your fill in the blank notes, the first one is the 45, 45, 90. So it says in a 45, 45, 90 triangle, the hypotenuse is square root of 2 times as long as each leg. So what they are saying is if you have a 45, 45, 90, because you have two 45 degree angles, your two legs are going to be identical. So let's say this is some side length, we'll call it x. That means this side length over here is also the same length, call it x. And instead of doing the Pythagorean theorem to get the length of the hypotenuse, what you could do is just take your leg, which we're calling x, and multiply it by square root of 2. So an example with some numbers in it, let's just say I had a 45, 45, 90. So I knew I had a right angle, and I had 45 degrees, and let's say I had a leg that was 7. Then I know this leg also has to be 7. And you don't need to do the Pythagorean theorem. You can just use this pattern. You can say, well, if this is 7, then the hypotenuse must be 7 multiplied by the square root of 2. And that's going to hold true for any side length. So if I had maybe a side length of 3, then this would be 3, and this would have to be 3 multiplied by square root of 2. So you're going to multiply by square root of 2 if you know the length of the leg to get to the hypotenuse. And going the other way, let's say you knew the hypotenuse, how would you get back to the leg? Well, what's the opposite of multiplying? You would divide by the square root of 2. So if I was given a hypotenuse to start, let's say I knew my hypotenuse was 5 square roots of 2. Well, if you multiply by square root of 2 to get to the hypotenuse, well, how do I get back to the original leg? You're going to divide by square root of 2, so undo that multiplying. And then if you cancel common factors, you get to 5. So if your leg is 5, if you multiply it by square root of 2, you get the hypotenuse. If you divide by square root of 2, you get back to the leg. So you need to kind of pay attention to which direction you're going with that relationship. So it's whatever the leg is multiplied by square root of 2 to go forwards, or to go the other way with it, you can divide by square root of 2. So what you want to memorize is this special relationship right here. And let's go ahead and look at the other pattern. So the other one is going to be for a 30, 60, 90. So it says in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3. So radical 3 times as long as the shorter leg. And that's a lot of words to keep track of. It's kind of easier to see it in a picture. So let's see what they're saying in the picture. So let's say we have a triangle where we have a right angle, and we have a 30-degree angle and a 60-degree angle. So which one's always going to be the shorter leg that they're talking about? The shorter leg is always going to be the one across from the smaller angle. So in this case, the shorter leg is going to be the one across from the 30. And this whole pattern is based off of knowing what the shorter leg is. So if we call the shorter leg some unknown length, we'll call it x. Then what does it say about the hypotenuse? It said the hypotenuse is twice as long as that shorter leg. So whatever x is, the hypotenuse is going to be 2 times bigger. So we'll call that 2x. And then it says the longer leg is radical 3 times as long as the shorter leg. So if the shorter leg is x, then the longer leg, which is the one across from the 60, so this one, the longer leg, the one across from the 60, is radical 3 times bigger than side x. So we'll call it x multiplied by radical 3. So that's the pattern in picture form. That's how I remember it. I would probably just remember that picture, and then you can go from there. So everything is in reference to that short leg. And if you know that, you're going to multiply by 2 to get to the hypotenuse. So you would multiply by 2 to get to the hypotenuse, or you would multiply by radical 3 to get to that longer leg. And then just like the last example, if you have other parts of the triangle and you want to work the pattern backwards, you can divide by 2 to go backwards to get from the hypotenuse back to the short leg, or divide by radical 3 if you have this one to get back to the short leg. But everything is in reference to knowing that short leg. So let's do a few examples. So we'll start out kind of easy. They'll give us the short leg. So let's say this is my 30, and they say this is 4. Well, how do you get to the hypotenuse? What did we say you had to do? You had to double it. So you're going to multiply by 2 to go from the short leg to the hypotenuse. So 4 times 2 should get you 8. And how do you get from the one across from the 60? So if this is the 30, the 60 must be over here. And what did the pattern say? To go from the short leg to the longer leg, you're going to multiply by radical 3. So that's going to be 4 square roots of 3. So that is working in the pattern, what I would call the forwards direction. So the pattern is based off of knowing the short leg. I kind of call that the home base, the one across from the 30. So if you know that, you're going to double it to get to 8, or multiply it by radical 3 to get to the one across from the 60. Now let's do another example. So let's say I had this as my right triangle, and let's say this was my 30, and this was a 7, So how do you get to the hypotenuse? You're going to double it, so times 2, so that's going to be 14. And how do I get to the one across from the 60? That's going to be multiplied by radical 3, so 7 radical 3. So there's your 3 side lengths, a 7, a 14, and a 7 radical 3. And let's do one more easy one. So here's my right angle. Let's say my 30-degree angle is over here now, which means my 60-degree angle is up here. And let's say they told me the short leg, the one across from the 30, is a 2. So how do I get to the hypotenuse? I just want to double it, so that will be 4. And how do I get to the one across from the 60? Multiply it by radical 3, so that will be 2 radical 3. And there's going to be your 3 side lengths. And let's go ahead and do one where we have to do the process backwards. So let's say we have this. And what we're going to know this time, let's say we know that this is going to be 8. So notice they don't give you the short leg, they actually give you the hypotenuse, but we know to get from the short leg to the hypotenuse you're going to multiply by 2 to get there. But we're going to go backwards. We know the hypotenuse, so what's the opposite of multiplying by 2? You're going to need to cut it in half or divide by 2, so this will be 4. So that's going to get you the relationship where this is 4 and this is twice as big, that's 8. And now that you know the short leg, how do we get from the short leg to the one across from the 60? Multiply it by radical 3, so that's going to be 4 radical 3. And that should be your 3 side lengths. And if we do another one, so let's say this time they give you a side length that's across from the 60. So let's say maybe they said this was a 7. Well, to get from the short leg, the one across from the 30, so we don't know what this is, but we know if we did know what this is, how would we get from the short leg to the longer leg? You would multiply by radical 3. So what's the opposite of multiplying by radical 3? You're going to divide by radical 3 to get back to where you came from. So you're going to divide by radical 3. So we'll call this 7 divided by radical 3. And then you can go ahead and rationalize that. We can get the radical out of the denominator. So radical 3 times radical 3 down bottom, that's going to get you square root of 9, which is just 3. And then up top in the numerator, 7 times the square root of 3 is 7 square roots of 3. So there's our simplified side length, 7 radical 3 over 3. And now that we know what the short leg is, which is 7 radical 3 over 3, how do we get from the short leg to the hypotenuse? We're going to double that. So it's going to be 2 times, what's our short leg? 7 radical 3 over 3, and then you can just work out the arithmetic. So 2 times 7 radical 3 is 14 radical 3 all over 3. So there is our hypotenuse. So this is going to be the side length for the hypotenuse, this is the side length for that short leg, and this was the side length that we started with that was across from the 60. So we were working the pattern backwards, so we had to divide by radical 3.